Copy 724, right. Center maintains 2000.
Center maintain 2074.
Comment 504 to center maintain 3000.
3000, comment 504.
In this video, we're going to be covering some basic calculations and some cross-country scenarios. So first thing is like some calculations here. What if you have been flying for 25 minutes, right? And the distance you covered is 47 nautical miles. The answer, what's going to be the speed? So the speed at which you will be flying is 113 knots. And how do we come to that? Would be like, let's just say that basically over here the 25 needs to be converted to an hour, right? For that we'll just divide 25 by 60 and then multiply and then that's the time, right? And what is the speed? Speed is equal to distance over time. So if we want to know, so the distance was 47, so 47 divided by 0.41, let's say, so that is almost 115 knots. So similarly, what if you have been flying, you have covered 84 nautical miles, right? And you have been flying for at 139 knots. So what will be the time, like how much time you have flown the airplane? So now we have the speed, we have distance, we want to calculate the time. So the time is gonna be equal to distance over speed. So that would basically be 84 divided by 139, and you can just multiply it by 60. Yes, so that would be 36 minutes. Okay, and the third is like, let's say the speed is given 85 knots, right? And you have been flying 51 minutes. So what's going to be the distance? Again, speed is given, distance over time. So that means that the distance is going to be speed into time. So again, the first thing is that the 51 needs to be in minutes. So that would become 0.85 multiplied by the speed, which is 85. So the distance you have covered is 72 nautical miles. Very simple. Another simple calculation is like when we have the gallons per hour, right? Let's say if we have 9.3 gallons per hour, which our airplane does, gallons per hour, and the time you have flown is 1 hour and 27 minutes. So how many gallons you have consumed? Again, the only thing troubling here is like this is not an hour, so 27 needs to be converted to hours first. That is 45.45 hours plus 1, that would be our time. And then the rest is that the GPH is just the gallons per hour. So we can just multiply this thing with 9.3 and it would tell us that it's almost 13.5 gallons. Okay, let's say if you have been flying for 2 hours and 13 minutes, right? And you have consumed 32 gallons. So what is your gallons per hour? Again, the 2 hours 13 minutes needs to be converted to hours. So it is actually 2.2 21. Okay, and then that is one. Okay, good. That is, and then 32 divided by 2.21 would be 2.22. So the 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 gallons per hour is gonna be 14.4. And the last and the same answer is like in the same similar question would be, if they have given you that the gallons consumed is 38, right, and the gallons per hour has been provided, which is 10.8. This is the gallons per hour, right? What would be the time, right? So again, the this thing should be equals to gallons per hour. So we're just gonna be dividing 38 divided by 10.8, which would give us, so the hours are gonna be equal to gallons per hour, which would make it 3.5, which means just 3 hours and 30 minutes, or 31 minutes. Yeah. Another set of calculations are like, what if we have been given the altitude, which is 10,000 feet, right? And the IAS, the indicated airspeed, has been provided 115, and they're asking for the true airspeed. So the rule of thumb is, without getting into very nerdy formulas here, with every 1000 increase in the altitude, there's gonna be 2 knots increase in the true airspeed. So in 1000 increase in the airspeed, 2 knots in the 1000 feet increase in the altitude, there's gonna be increment of 2 knots for the true airspeed. In order to make sense of it, is that when the airplane is going high in the altitude, the air becomes thinner and there is less resistance. That's why the airplane moves much more faster compared to what the indicated airspeed is showing. So we are here at 10,000 feet, so that's gonna if we divide it by 1000, that would make it a factor of 10 multiplied by 2 knots. That means that we're gonna have an extra 20 knots. So the true airspeed is gonna be 115 plus 20, which is 135. Another one would be the indicated airspeed is 103. The altitude is 6,000. So what would be the true airspeed? Again, the factor is gonna be 6, because 6,000 divided by 1000, sorry, multiplied by 2. So the factor which it's gonna be the factor is gonna be 6, but with every factor we have a 2 increment of 2 knots, so that's gonna make it 12. So this is gonna be equal to 115 knots. Okay, along the same lines, this is going to be the last one. What if we have the IAS equal to 115, right, and the altitude is 11,000? Again, 11,000 divided by 1000 multiplied by 2 is going to be the increment in the speed, which would make it 22, and the true airspeed is going to be equal to 115 plus 22, which is going to make it 137 knots. Okay, now I'm just going to be covering some scenarios here. It's just a flight log example, right? So VFR, if we have to make a VFR flight plan, and you know that the pre-flight planning is extremely important. So a vice pilot ensures a successful cross-country flight by getting a good pre-flight briefing, completing a flight log, and filling a flight plan before flight. So we're gonna go through the steps how we're gonna be doing it. So again, we are covering a VFR flight plan. The first step is that we're going to be getting a pre-flight briefing consisting of the latest and the most current weather, airport, NAVAD information, those kind of things. Then the second thing is to draw course lines and mark checkpoints on the chart. Then we're going to be entering the checkpoints on the log. Then we're going to be entering the NAVADs on the log. Then we're going to be entering VOR courses on the log. Again, these are best even if you have a handheld GPS device. You should be doing that. Then we're going to be entering the altitude on the log, entering the wind direction and the temperature on the log. Measure the true course on the chart and enter it on the log. Then we're going to be computing the true airspeed and entering it into the log. Then we're going to be computing the WCA and GS and enter them on the log. Then determining the variation from the chart and that we're going to be putting it in the log. Determining the deviation from compass correction card. Again, putting them in the log. Then we're going to be putting the compass heading. Then measuring the distance on the chart, and that we're going to be making note of that. We're going to be figuring out the ETE and the ETA, right? And then enter them on the log. Calculate the fuel burn and usage, and again this should also be noted down. We're going to be computing the weight and balance. We're going to be computing the takeoff and landing performance, and we're going to be completing a flight plan form, and then we're going to be filing that flight plan with the FSS. Okay, after takeoff, you attempt to activate your VFR flight plan, but you are unable to contact the FSS. So, what will happen to the flight plan? So, what happens is like when a VFR flight plan is filed, it is held by the FSS until 1 hour after the proposed departure time, and then it is cancelled if you don't activate it. Okay, now the diversion to alternate lost procedure. So let's say we have what action should we take? Like if we become disoriented, or we have lost on a cross-country flight. So there are going to be multiple conditions we're going to be covering. The first condition is that we have plenty of fuel, right? We have enough fuel and the weather conditions are good. Right. So in this one, we're gonna be straighten up and fly right. Even though we are disoriented, we don't know where we are going. So fly a specific heading in a direction you believe to be correct, or circle if unsure, but just don't wander aimlessly. If you have been flying a steady compass heading and keeping a relatively accurate navigation log, it's not likely you will have a problem locating your position. If several VORs are within reception distance, use them for a cross bearing to determine position. Even a single VOR can be of enormous help in narrowing down your possible position. Or fly to the station and there's no doubt where you can you are then. Use knowledge of your last known position, elapsed time, approximate wind direction, and ground speed to establish how far you may have traveled since your last checkpoint. Use this distance as a radius and draw a semicircle ahead of your last known position on chart. For example, you estimate your ground speed at 120 knots. If you have been flying 20 minutes since your last checkpoint, then the no wind radius of your semicircle is 40 miles projected along the direction of your estimated track. If still unsure of your position, loosen up the eyeballs and start some first class pilotage. Look for something big. Don't concern yourself with the minutes or trivial at this point. Often there will be a linear feature such as river, mountain, range, or prominent highways and railroads that are easy to identify. You can use them simply as references for orientation purposes and thus find them of great value in fixing your approximate position. And the third one is the same thing. You are distorted, but let's say you are low on the fuel and the weather is bad. First thing is get it on the ground. Most accidents on the are the product of mistakes which have multiplied over a period of time, and getting lost in is no exception. Don't push your luck, right? And now wanna so let's say if you are not able to locate your position, what action should be you do? So remember the FCC recommends the use of 4 C's. What are these 4 C's? First one is the climb. Second one is communicate. Third one is confess. And the fourth one is comply. What it means is like the higher altitude allows better communication capabilities as well as better visual range of identification of landmarks. That's why you should climb first. Use the system. Use Normally we use 101 to 1.5 megahertz if no other frequency produces results. It is guarded by the FSS control towers, military towers, approach control facilities, and other like the traffic control centers. Confess. What it means is like once communication are established, let them know your problem, and then the comply means that follow the instructions. Okay, the last thing I wanted to cover was, so let's say there is a scenario that you are en route on a cross country flight. The weather is very bad. It's been deteriorated, and it has become necessary to divert to an alternate airport. Assume that you are not having any GPS or DME capability. So describe like how would you navigate to the alternate. So what I would do is like after selecting my alternate, right, I will approximate the magnetic course to the alternate using a straight edge and a compass rose from a nearby VOR or an airway that closely parallels my direction to the alternate. Okay, we can also use the straight. I will say that I can also use the straight edge and scale at the bottom of the chart to approximate a distance to the alternate. I can fine tune this course and distance later as time permits with a plotter. Okay, then if time permits, I will start my diversion over a prominent ground feature. However, if it is an emergency, I will divert promptly towards my alternate. Those were the things I wanted to cover related to the diversion and how you would approach that. These were the things I wanted to cover. Thanks for watching.